we will compare the control system. Like the major control system we are discussing here are 4 control system, in one of which is not basically control system but a software layer, but majorly these are 4: the DCS, the PLC, the SCADA, and the RTU. Those 4 are under the consideration, like here. Comparison is based on 2 things. One is historical background, another is a compare and contrast method. What some element, some component has but other don't have. So let me start. So the historical background, like before the PLCs, how processes were being controlled, what was the way, what were the methodologies. It was actually the relays which were used for controlling the discrete functions, the discrete processes. And for the continuous processes, there was a PID controller, a hard form, in the hard form, which were used for the continuous process. I must mention, before going to the comparison, you must know that there are basically and majorly two types of processes in a control and automation industry. One is discrete control, another is continuous control, which we can call as analog control. So when we go towards the historical background, PLC replaced those initially. PLC replaced those relays, the old way of functioning the machines, the processes, and majorly it was used. The PLC was used for controlling discrete processes, and after some times, like we were controlling the process, but we were blind. We didn't know what is happening around, what is increasing, what component or what factor is decreasing. Is there any problem with the PLC? Is there any problem with the valve? Is there any problem with something in the field? So you didn't know about that. So how could you know that? Then there was a need for something like that, some interface, some visual graphics user interface, GUI. Sometimes we call it HMI, human machine interface, some call it SCADA. So this then arrived a SCADA, which helped to make control easier, better, visible, and it has many more. It has more than just HMI. It has more than just visual. It also gives you not only the data acquisition, not only the supervisory control, it also gives you the reports, the alarms. Those are things which keep you alert that something wrong is going on with the processes. So SCADA is actually, you must know, everybody must know that between the PLC and DCS, SCADA is a software layer. SCADA is not a hardware part. SCADA is not like you say that this, you can see, like I can point you towards something that this is SCADA. No, SCADA is a software layer which can be implemented on different workstation machines, computers. Okay, but when we talk about PLCs and DCS and PLCs are actually hardware component, actually computer, industrial computers. So PLC replaced the relays and were used for discrete processes. SCADA came in and it helped to make control more easier, better, and visible, and give you edge over reporting. Then DCS evolved and replaced the PID controllers, the hard PID controllers, and these DCS were majorly and primarily used for batch and continuous production processes, and after some time it has advanced in advanced control. So discrete PLC, SCADA, DCS, and then there is also RTU. RTU is a remote terminal unit, which is same thing like a PLC. There is no major difference between PLC and RTU, but RTU are specifically made for remote location, which are unattended. There is no human at those locations, and you have to go for some rotation, some after some periods to check and come back after 2 months, 5 months, 6 months, 1 month, few weeks. So those locations are remote location, they are unattended. So for that we needed, and there is no power, you cannot provide complete power to those areas. So power shortage, and then specifically if I mention some examples, onshore and offshore oil and gas wells. There's another examples of power distribution areas, like when you distribute your power through some assemblies, some cables. So they are always remote areas. So RTUs were primarily made for those remote location because they operate on solar panels and batteries, and importantly they are same like a PLC, but their structure is robust, they are strong, they can work in diverse and very harsh environments, like and what does I mean by harsh? It doesn't mean like the stone would be dropping on these RTUs, but by harsh we mean like there could be high temperature, there could be very low temperature, there could be some high pressure, some other like these sort of factors in which the common and the normal PLCs would not sustain. They would break down, they would melt down, they would stop functioning. Even though if they don't melt down, some PLCs after some higher temperature for 60 to 50, after that they stop working, they don't function in a proper way. So RTUs are best for those locations. So that is the historical background. Like we started from PLCs replacing the relays, we came towards the SCADA, which is a I would again mention that it is a software layer. Then we came after seeing the PLC and DCS working together, we saw, oh, we can make DCS. So how it evolved from PLC and SCADA, we made a DCS. What are the advantages of DCS and which is not available in SCADA? There's another part of discussion. SCADA is actually as I mentioned, PLC, when we implemented PLC, like you have two valves in the field, on-off valves, and you have two sensors. What did you do? You bring wires from those sensors to PLC, terminated it in the PLC, and through those two sensors you wrote a logic, and then there is another connection between two valves. So when sensor sends something, it closes and opens those on-off valve. But you don't know what is happening around there. Like in 1960s, the Modicon was the first who made the PLC. PLCs were implemented and it was adopted very rapidly by everyone. So if you implement the same way, like I told you, do two sensors, two valves, and in the middle there is a controller, input, controller, and output, but you don't know what is happening around. You must have a control, data acquisition and supervisory control. So you can if the sensor doesn't sense the right value and it can shut down your valve, what you can't do anything if you don't have SCADA. What SCADA gives you an edge over those sensors and valves to control it from a software like human machine interface, from graphics user interface. So that's the advantage of SCADA. Now you are not that much blind, you can control it in a better way. Then there comes DCS. How DCS evolved? DCS is exactly evolved from that idea, from PLC to SCADA. When you combine PLC SCADA, DCS is the same thing, but it has some more advantages. So PLC is hardware piece, hardware logical industrial computer. SCADA is a software piece. You install it in your computer and you connect with that hardware piece. Now whatever the hardware piece is performing, like whatever the function it has been carried out by the PLC, you can see it in the SCADA, in the software, based on how you program the SCADA. Like it's not like automatically you will install a SCADA and it will be, no, you will have to program it accordingly. Now you can easily monitor the PLC from your SCADA, and that's it. Now when we comes to a DCS, when we were talking about the PLC and the SCADA, everyone was installing the PLC and SCADA. There were need of different PLCs. There were need of many PLCs. Like I installed Siemens PLC in my plant. If in 1970s, like 1980s and 90s, I had to install different PLCs. Initially, I started my working on Siemens PLC. After some time, I need another expansion. I need to expand my plant. So I acquired another PLC. So what was the issue? The issue was the communication between those two PLCs. There were some problems. Those PLCs were not able. The communication was not open. Even if you implement the SCADA, sometimes SCADA could get the data from the Siemens but not from the Allen Bradley. I am giving you just an example. Sometimes the SCADA would get data from the Allen Bradley but not from the Siemens. That was a major issue. And also there was another issue, like if you install different vendors system, Siemens, Allen Bradley, Bedrock, and some others, Modicon. Now when there is some problem in your system, who are you going to call for support? Which vendor? There are many vendors. For Modicon, you will have to call the Modicon Schneider people. For the Allen Bradley, you call Rockwell. For the Siemens, you will call the Siemens guy. And there might be system integrators, but who are not that good at those times, which are nowadays very quite good in those things. So who would they call for support? Who would troubleshoot those things? That was the major issue, and there were some other issues as well. So there was an idea. There came an idea of DCS. Like if I create, there was another thing as well. Let me mention that before coming toward the DCS idea. Another thing was the PLC. You will have to control all the processes in one main controller, the PLC. PLC was the whole thing. If your PLC is down, your process is down, your productivity is down, you may cost a lot of money. So your process was centralized in one programmable logic controller, which were monitored by a SCADA. So I mentioned three issues. One issue, the connectivity communication issue of different products. The second issue was with the support, and the third issue was when my PLC is down, my process is down, my whole process is down, not the part of my process. So it might cost me money, it might cost me time, it might cost me many things. So idea came up, DCS. So the DCS, what is the DCS? DCS is actually a proprietary and turnkey solution. Like it has the SCADA part as well. It has the PLC part, but that is in a modified shape. Like it is not the same PLC. It has the controllers, but it has different features. It has also the PLC feature, but it has also added features, which we will discuss in next slide after the break. So the idea came for DCS, which has SCADA part, which has PLC part, which has the advantages over PLC and SCADA, which features were not available in those, and also they added some more features, and its supports was so much easy. Like if you install, your install base is Delta V DCS, and Delta V DCS might have 10-20 controllers. You have installed 20-30 controllers in your plant. So prior to that, you had 10 to 20 vendors. Now you have only one vendor. You have to call the Emerson, have this problem. Even if you call a system integrators, control and automation engineer, he might not go through many different systems, not Emerson and Siemens, Allen Bradley, but he has to go through only one system, and he can support you easily. So that was the focal point, that was the focus of DCS, which has improved the PLCs and DCS, PLCs and SCADA.